Hello everyone. Today I will going to showing a lecture on pile cap design. There is a question on this pile cap design will be on the building. Let's start. A 30 story or 30 story residential building will be built and Navishing City design the pile cap of column. Column size is 47 into 47. We can show is below. Here is a figure of top view, and pile dia 2.2 feet and the pile bearing capacity to 18 feet. As you may compressive strength of column of 4 KSI, Fy is 60 KSI, and height of the each floor is 10 feet. At first we have to calculate that dead load self weight of slab and floor finishing and normal and column, and slab thickness is 6 and unit weight of concrete 0.150 and 2 3 is a tributary length in here is a tributary length as 23 by 2 and left right portion also 23 by 2, so total will be 23 feet. And in the same way here is a 20 divided by 2 and 20 divided 2, so it will be 20. So this is the tributary length, and 30 is a story, number of stories 30. And in the same way floor finishing thickness and unit weight of thickness and tributary area, and 30 is the number of story. In the same way random wall 5 is the thickness, tributary 10 into 23, and unit weight of bricks is 1.120 and 300. In the same way column is 47 into 47. 10 is a height and 0.15 is a unit weight, and 29 is number of story. Number of story will be less than 1. Okay. And live load we know the 43 psi as per code, and 23 into 20 is a unit weight, and 330 is the number of story. So our live load 5 length 3.4 kip, and dead load plus live load 1.2 320, and number of piles will be 1.1 dead load plus live load divided by pile bearing capacity. We have found the pile bearing capacity from geotechnical report 218, and we have shown our number of pile is found 16 piles have found. And now we will going to layout of the plan. This is the very important for layout of the plan for pile cap design. Pile to pile distance we know pi d or 3d, which is 7 feet. Here is a one pile to another pile. One pile to another pile distance will be 7 feet. Okay, so here is the 7 feet, 7 feet, 7 feet, 7 feet, and 1.6 is a clear distance from pile center to the edge of the pile cap. Okay, LX and LY 3 into 5. 3 spacing 1 2 3 3 split into 7 into 2.2 divided by 2 in 5 and 2 is 24.2 LX and LY also 24.2. Now we'll go to calculate the x1 is nothing. X1 is a CG distance of CG from pile surface, edge of the column face, not CG of the column face. Let's see how I have calculated here. Here is 7 by 2. Here is a 7 pile to pile distance 7, bhag 2 divided by 2 divided by 2 means is column CG. Then we have deduct the column half of the column. Here is a 47 column dimension divided by 2 and divided by 12, which is converted to the feet. That means we have calculated this phase of the column to the CG of the file. Then we have found 1.5 feet. In the same way, x2, here is the second row of the column, second row of the files. X1 is the first row of the column, first row of the first row of the file, and x2 is the second row of the files. X2 is in the same way we have calculated by in the same way we have calculated here, which is 7 divided by 2 minus 47 divided by 12 minus 2, which is here, and then pile to pile distance we know means 7. That's why we have gone on the face of the column to the second row of the distance, which is x2. Okay. So moment analysis here is n divided by total number of pile. We have found 16. Total number of pile is 16, and 4 is the first row of the piles, 1 2 3 4, and 4, and x1 is the first distance of the first row of the pile from column face here. In the same way for second, n divided by total piles. Here the total piles, and 4 is not first row, this is the second row. So if we get the 6 number of piles, then we have to use here 6 number of piles instead of 4. Okay, in x2 is the second CG of the piles, and found 9626 feet. Okay, now we will check the punching of the column. As we know, the punching of the pile cap, which is C plus D. Here is D by 2 plus C is column, and D by 2. So we have called here C plus D. Here we know n is the load and 16 is the total number of pile, and if we know the cover C plus D, if we see here, C plus D is cover only 4 columns, and rest of the 6 column is out of the C plus D. That's why we have taken the 12 column, as 12 column is out of the C plus D. Okay, so AP area of perimeter 4 into P plus D into D. 4 into P, we know the pile dia 2.2 into multiply into 12, which is converted to inch, and D plus D. We know the share of the share capacity is 4 into pi root over f prime c f p, 4 into pi 0.75 f prime c 300, 3000 divided by 100, and 4 into 2.2 into 12 into D into D, and we have found this equation. So first equation and second equation we have comparison and found the minimum dia of pile cap is needed. The minimum depth of the pile cap is needed 49.6 inches. Okay, it is found from punching shear. Now we will see the flexural shear. We know the total load and the total number of piles. If we know the total number of piles here 16, and 4, why we have found this 4? The flexural shear is found in distance of D. On the other hand, we have seen here the punching shear is found here C plus D or D by 2D at distance of D by 2. Okay, the flexural shear is found at distance of D. That's why if you calculate C plus D, then we have shown here the pile arrangement, only 4 piles in taking all the loads. Here the 16 piles is the 4 piles. How much pile have taken this load? Only 4 piles. That's why we have calculated only 4. Okay, and found 995. In the same way, we know the flexural shear capacity 2 into 5 root over F times BD. B is Lx or Ly. Here we have already known the BD or Blex is the length of pile cap. Here to 24 into 2 or 24 into 2. And D, here is the another equation we have written here, and found equation, solving this equation 3 and 4, and found D is 2.89 or 34.86 inches. So we have found two type of depth of pile cap. One is 49.6 from punching shear, and another is from flexural shear, which is distance of D, and found 34.6. So we will use the maximum value, and we have to provide 50 inches thickness of the pile cap. So as you know, the reinforcement A is equal to 0.85 F times Fy, and found here is a B is a 24.2 and multiply into 20, and putting all this value here, and find the AS is to 43.95 inches square. Minimum reinforcement is 48.49. So minimum reinforcement is governed, as we have found the main reinforcement, which is 43.95 inches square, and minimum reinforcement 48.4 inches square. So we'll use for minimum reinforcement. Uses a number 8 bar, and the area of 8 bar is 0.79 inches square. So number of bar is 61 or 62 UAP. Spacing B by 2, which is 4.75 inches square, center by center in both direction. So we can see how we have used 4.75 inches square, center by center. Here is our pile cap, and here is the pile cap length is 24.2, and Ly is same. So this is the number 8 number bar at the rate of 4.75 center by center in both direction. This is the main this is the detailing of the pile cap. Here is the extension in both the y direction. Both will be used 4.75 inches square, center by center. I hope you all are enjoyed this lecture, and you will find something. Before I am leaving, I want to say that one thing is punching shear is occurred D by 2 distance, and flexural shear is occurred only D distance. So we have BP equal to N into 16 to 12. N is total load, and divided by total number of pile. Total load divided by total number of pile, and we have multiplied by 12. Why we have multiplied 12? 12 because this is the piles where outer of the C plus D. And on the other hand, we have seen here the flexural shear, which is the distance of D, only distance of D. So number of total load divided by total number of piles, and only 4 piles are taken the share, only 4 piles. If we see the in this layout, then we can see here only this portion will take the flexural, or only this portion will be take flexural, because this portion is distance from D, this portion will be distance from D, that's why we will take this 4. Okay, I hope you all are understand my talk. Thank you.